Good morning students. We will see in this video the numerical of electrical power system. Okay, this video is for that student, those who were absent in the class, or you can say those students having the difficulty. Okay, now see, this is one numerical. In this there are two generators are given. This is one transformer. In this particular numerical, transmission line is not given. The parameters of transmission lines are not given. So what is given in the G1 and G2 parameters? See, the rating of G1 is given as a 30 MVA, 11 kV, and the subtransient reactance, that is X double dash, is equals to 0.2 per unit. Now the rating of G2 is 25 MVA, 11 kV, and X double dash is equals to 0.25 per unit. So, and the particular parameter of your transformer, the transformer is delta star. That means the primary consists of delta and the connection of secondary is star. So the rating of your transformer is 60 MVA, 11 by 66 kV. The voltage rating is 11 by 66 kV, and the per unit value of reactance is 0.10. Okay, now what you have to do first of all? What is the aim of this question is that you have to find out you have to draw the reactance diagram. Basically, in such type of numericals, you have to find out the reactance diagram. For that, you have to calculate the reactance of each parameters. That means G1, G2 and transformer. Three things are given, three elements are given. So one is G1, another is G2, another and third one is transformer. So you have to find out the parameter, that means reactance of G1, G2, that is the new reactance of G1, G2 and transformer. So we will start with your sections. Sections means how to start the numerical. You have to divide this particular diagram, single line power system is into a section. So I am dividing this particular power system into, this is section 1. So for that I am considering your VB as 11 kV. This is section 2. I am considering your VB, that is the base voltage, that is 66 kV. So this is our base voltages. Now what you have to do? You have to take the base. So I already told you that when you are taking the base, new base, then the new base is having for G1, G2 and X, we are taking the same base, MVA base and kV base. So this is nothing but a kV base, 11 kV and 66 kV. But talking about the MVA base, in this numerical, in this particular numerical, the 11, the reactance, not reactance, the particular base, MVA base is given. So you have to consider that only. Otherwise, what will happen? You have to take the larger rating as a base, or you can say round total like 10, 100, 1000. But in this numerical, the base is given. You have to calculate the reactance for 25 MVA. 25 MVA. Okay. So what you have to do? This is nothing but your new base. This is called as a new base. So MVA base, new base is nothing but 25 MVA. So we can write it down like SB new or SB2. In some books it is given as SB new, in some books it is given as SB2. So, or you can say it is SB2. So it is nothing but 25 MVA. Okay, so this is a base, that is nothing but 25 MVA. Okay, now what you have to do? You have one formula, and that formula is nothing but when you are calculating the value of Z, that is Z2 or Z new, Z2 or you can say Z new, the formula is Z1, that means nothing but the old one, that is in per unit. This is in per unit. This is in per unit, multiplied by SB new, or you can say 2. It is new or 2, divided by SB1, that is old. SB1, that is old. Okay, multiplied by VB1, that is a old value. VB1, old value, divided by VB2, that is the new value. Okay, and this will be total whole square. Okay, this will be total whole square. So what is the formula? If you are calculating Z2 new per unit, that is equals to Z1 old per unit into SB2 new, SB2. Either you can say 2 or new. Okay, so SB2 or new, SB1 or old into VB1 divided by VB2 whole square. Okay, now what is our aim? Our aim is to find out the value of X2 per unit, X2 in the sense X new of generator. So first is we have to calculate. Have you understood this? I am repeating what we are taking. The old value are given like this 30, 25. Okay, for generator 1, generator 2, and the new value of base that is given. So you have to take that base only, that is SB new or SB2, that is 25 MVA. Now you have to find out, the main aim is to find out the value of X2 per unit. So X2 per unit for generator 1. This is X new or X2 per unit for generator 1 is equals to, follow the formula. The formula is, what is the formula? That is X1 per unit. Okay, then SB2, that is SB new divided by SB1 into VB1 divided by VB2, that is a whole square. So now what you have to do? You have to put the values in this particular formula. So what is the values? X1 for generator 1. So generator 1, this is nothing but 0.2. See here, this is nothing but 0.2. So that is equals to 0.2 into multiplied by SB1. So SB2, first is SB2. So SB2 is this, that is 25, new value of base 25 divided by SB1. SB1 is given, this is 30 MVA, the generator rating 30 MVA. So therefore it is 30 MVA multiplied by VB1. So what is VB1 now? So VB1 is nothing but this 11 kV. So it is 11 kV divided by, now what is the base? See here, the base is 11 kV again. So therefore it is a 11 kV and that is whole square. Understood? What I am saying, that you have to find out the value of X2 for generator 1. So X1, so 0.2, then 0.20 or 0.2, then 25 divided by 30, that is SB2 divided by SB1. Now VB1 divided by VB2, that is 11 by 11 whole square. So after calculating, the value should be, the value you are getting is, I am writing down in a different color. Different color I am writing down the answer to just clear the things. The value is it is 0.1667 per unit. This is your answer. This is your answer. In similar way, you have to find out the value of X2 for generator 2. So X2 per unit for generator 2, again the formula is same. Okay, so what is the formula for that? Again X1 per unit, SB2 divided by SB1 into VB1 divided by VB2 whole square. So now for generator 2, X1 is this 0.25. So therefore 0.25, that is in per unit, multiplied by, now for SB2 is same, that is 25. So 25 divided by SB1. SB1 is given for generator 2 is 25 MVA. So therefore it is 25. Then VB1, again VB1 is 11. Then for this is again it is 11. So therefore 11, see here 11, this is VB2, this is VB2 for transformer. So this is 11 by 11 whole square. Understood what I am saying? See, once again I am telling you what we are doing. We are taking one section. In this section 2 generators are there, and this section we are taking the transformer. So we have selected the base, that is 11 kV, and the given voltage is 11 kV. Here also it is 11 kV. So therefore 11 by 11, both cases we are having 11 by 11. So that is equals to, the answer should be, so answer is, if you are calculating this, the answer is 0.25 per unit. That means we are getting the same value that here. Why? Because this is 0.25, 25, 25 get cancelled, 11, 11 get cancelled. So therefore the remaining is 0.25. So this is nothing but x2 per unit. For generator 2, we are getting 0.25. Now, last part is you have to calculate for transformer. You have to calculate for transformer. Again the formula is same, but this is x2 per unit for transformer. x2 per unit for transformer. Again the things are same. The formula is same. If it is transmission line, then the formula gets differ. So I will tell you later on. Okay. So this now see the rating. What is the x value? X value is 0.1. So therefore it is 0.1 multiplied by what is SB2 for this transformer? SB2 again it is same, that is 25 divided by, now for transformer what is the rating of S? S is 60. So therefore 25 divided by 60. Okay, 25 divided by 60. Now base value. So base is again your base is 66. Your base is 66. Okay, but what you are doing now? What you are doing now? It is into 11 by 11 whole square. So what you are getting? Your value should be 0.0416 per unit. So these are the calculations for reactance, new reactance of G1, G2 and transformer. Now what is the basic thing required in this? You have to make reactance diagram. From this single line diagram, we have to draw the reactance diagram. Have understood what we are doing? Just summarize the thing. 25 MVA, that is the given. So therefore your new base is 25 MVA. G1 rating is given like this, 30, 11 and 0.2. Then G2 is rating 25. This we are given. We are divided into two sections. So we have to convert that 66 divided by 11. So now these are the things, that the formula is x2 per unit or z2 per unit is equals to z1 old per unit sb2 new divided by sb1 old, the vb1 old divided by vb2 new. So in this way you have to calculate the new value of x2 for generator 1, generator 2 and generator 1, generator 2 and transformer. Now you have to draw the reactance diagram and you have to write down these particular values. So how to draw the reactance diagram? So what is the basic aim? That we have to draw the reactance diagram like this, and then we are so the diagram is like this. See how many generators are there? Generators are 2. So there is a that 2 are in parallel. So therefore this is one generator like this. This is reactance of that generator. Then another generator. These two are in parallel. So this is generator 2 and this is transformer reactance. So what is the value? The value is, now you have to write, this is the reactance diagram. So now you have to write down this is G2, this is G1. Okay. Now the reactance value. क्या मिली थी अपन को reactance? That is 0.1667. You will check the value. Maybe some difference will be there in the values. You can check the values. Okay. Then this is 0.25 per unit, and this is nothing but 0.0416 per unit. So this is called as a reactance diagram. So students, this is for you only, that if you are having difficulty, you can take this video and see what are the particular steps are given or what are the steps for solving the numerical. Okay. So in this way you have to solve the new values of reactance and you have to draw the reactance diagram. So I am just telling you one more time that while drawing the reactance diagram, you have to first take the parameters. So this there are two generators which are in parallel. One is transformer. So therefore this is generator 1 and this is generator 2. Both are in parallel. Considering the reactances. This is reactance for G1 and this is reactance for G2, and now this is in series with your transformer, so therefore this is reactance for transformer. I hope student this numerical will help you to solve your difficulties. Okay, thank you.